This is Algebra 2. This is an example of a three-variable system with three equations. This is Objective 8. So here's another example, so you have something to look at hopefully while you're doing your homework or you're struggling on any types of questions. So you can see here I've got three different equations. I color-coded them, and what I need to do, this is always our first step, is to create two new equations with two variables and that are the same. So I need to use these three to create two new equations. So the process which I'm about to do, I have to do it twice. So first things are first, picking a variable to get rid of. And kind of looking at it, there's not one that really sticks out. I'm going to go get rid of y. So this is, I'm just going to put a little note here that I need to get rid of y's twice. Yeah, I'll get rid of the y's twice. So just pick any two and get rid of the y. Looking at, I'm going to go with the green one and the pink one. So I'm going to rewrite the green one. I'm going to call this step 1. Okay. I'm going to rewrite the green one here, and you can see I'm going to go with 2 and negative 2. So I got to multiply that bottom one. So I'm looking at 4x plus 2y plus 3z equals 1. Now I'm going to get rid of the y, so I can see that this is a positive 2, that's negative 1. So I'm going to multiply this bottom one by positive 2. So I'm looking at 12x minus 2y plus 8z equals negative 2. And then from here, I'll go ahead and add the actual equations. And you can see that was the whole goal. And now I'm looking at 16x plus 11z equals negative 1. There's one of the equations that I need. Okay. So now I need to do that process again, get rid of y again, and at the same time, but I got to use two different equations, sorry. So I got to use one of them again, but I can't use the green one and the pink one. I got to use another combination of the two. So I'll go ahead and use the pink one and the red one here. So I'm going to go for 3 and negative 3. So here's a negative 3, so I'm going to multiply this one by negative 3. So I'm going to rewrite this one over here, the red one. Negative 14. And I'm taking this pink one, I'm going to multiply it by negative 3. And I get negative 18x plus 3y minus 12z equals positive 3. Okay. Then I'm going to add these two equations together, and I get negative 16x. Those go away, and then I get negative 7z equals negative 11. Alright, there's negative 11. So now, this was the whole goal, was to create these two new equations. So now I got a two-variable system with the same variables. Now, I'm going to treat this like we've done in the past. I'll go ahead and use elimination here. So this is going to be step number 2. Okay. The big mistake is people forget to get rid of the same variable twice in step number 1. So I'm going to rewrite this equation right here. 16x plus 11z equals negative 1. Bring this one down here. Negative 11. This works out nice. Those automatically cross out. I get 4z equals negative 12 divided by 4. And z equals negative 3. Okay. So I now have one variable solved for. I got z. Okay. So now I need to go ahead and go back and solve for x, and I'll plug it into this top equation, which is technically this one right here. This is still step 2. I get 16 times x, which I'm going to solve for, times 11 times negative 3 equals negative 1. I'm looking at 16x minus 33 equals negative 1. I'm going to add 33 to both sides, and I'm looking at 16x equals 32 divided by 16, and x equals positive 2. So now I have two of the three variables solved for. So now what I'm going to do is for step number 3 is I'm going to go back to the original equations up here, plug in z, plug in x for any particular equation, and solve for the third one. So I need to find out what y is. So I'll go ahead and I'll do this one right here, this pink one. So I'm going to kind of put step 3 up here so that I can keep it on the projection. Okay. So I'm plugging in z and x. So I know I'm going to say 6 times 2, that was x, minus y, that's what I'm solving for, plus 4 times z, which was negative 3, that equals negative 1. And I'm looking at 12 minus y minus 12 equals negative 1. Positive 12 and negative 12, those go away. And so I got negative y equals negative 1. So I divide negative 1 to both sides, and y is going to equal positive 1. So kind of coming back down here, remember our answer is technically a coordinate point. So it's x, y, and z. So our actual answer is going to be the coordinate point 2, 1, negative 3. 2, 1, negative 3. So remember, let's kind of recap what we just did. First thing was we took two different equations and we got rid of the same variable, and we did it twice. So I used the green one and the pink one, then I used the red one and the pink one. You just can't use the same two again. Get rid of the same variable. Then if you do that, you'll have a two-variable system of equations with the same variables. Treat that like we've been doing with substitution or elimination. Solve for one variable, go back, plug in for the other one. When you have two variables, pick one of these three equations up top, plug it back in, and solve for y.